Hello, it's Scott Manley here, and I am orbiting serenely above the planet Kerbin in my interplanetary spacecraft, the one which I used to go to Paul, if you remember, in my very first interplanetary mission attempt in Kerbal Space Program 0.18. Now, I'm going to do a little bit of a tutorial discussing what you need to know about flying to other planets. And the first thing I'm going to point right in this image. See that? That is a nuclear engine. For almost all your interplanetary operations, you want to be using the nuclear engines because they are so much more efficient than everything else. Almost all your operations for planetary transfers are going to be carried out in zero gravity. Therefore, the acceleration of these engines being low does not matter, but the efficiency is a huge win. So, nuclear engines are a huge win for interplanetary transfers. Anyway, the next thing to know is that you are starting out in orbit around the planet Kerbin. Now, to get to another planet, you need to go out a really long way. And you need to go out into an orbit which crosses one of the targets. Now, I've highlighted Duna as a target object here. So how do I get out towards that target? Well, I'm just going to start out on a circular orbit around Kerbin. If I add a maneuver here just after sunset and thrust up, and you see the enhanced maneuver node UI popping up here, if I go just enough, that's me escaping the planet Kerbin, and if I zoom out, you can see that I end up in an orbit which is very close to Kerbin's. I haven't gone very much, right? So that's me got just enough velocity to escape. So if I keep adding velocity now, that will be projecting me forwards in the orbit and ultimately bring me onto an orbit which crosses that of Duna. And there we go, just like that. However, if you look at the positions, the target close approach positions, I am way off. I'm nowhere near my target. So if you're going to go out, you want to burn just after dark. I can continue the increase this thrust up, and let's set Dres as my target. And of course it decides to hide my maneuver node way down in here again. Not very helpful. And I'm going to come out. Thankfully the scale on this doesn't change. So yeah, pulling this out, I can cross over Dres's orbit. And of course I won't get an encounter because it too will not end up anywhere near I am. Similarly, if I keep going and I double my initial velocity investment, I can get all the way out to Joule. Now, if I want to go inwards, what I have to do is burn at the other side of the planet. I want to burn just after sunrise, right? So let's grab the maneuver node and drag it away around. And then zoom out, and you'll see that we're now, instead of adding velocity to the planet's orbit, we're subtracting it. And I should actually bring this around a little. There we go. So that's more... Is that more in line with the orbit? Yes, there we go. That brings us more in line with the orbit. So you see that brings us down towards where Moho is. And if I set Moho as a target... Again, it doesn't show me any encounters. Well, so much for that. Now, the reason why, although I'm crossing these planets' orbits, I'm not arriving there at the same time. So, although you have the velocity is actually the easy part. It's the timing that's the hard part. You need to time it so that when you leave the planet Kerbin, you're going to travel this distance all the way around and get down here at the same time as the target planet. And that means you need to know the period of this planet, how far it goes around, and how long it takes to go around this. And you can do all this using simple orbital mechanics because you know that the period is a function of the semi-major axis, which is basically, or it's not even half, it's the average of the perihelion and the aphelion of each orbit. And so you can actually figure out that for a given target, you can measure an angle between your start position, Kerbin, the sun, and the planet. And that will tell you what time you need to burn, right? So for the planet Duna, you want to have roughly a 45 degrees. That means you would have Kerbin here, the sun here, and Duna would be about here, right? And that, if you burn, that would get you to Duna, assuming you go in the correct direction. Similarly, for Eve, you want it to be about 45 to 50 degrees behind you. So you would have Eve here, Sun, Kerbin. Now, I could go into the mathematics, but it's probably a lot easier if you go to a website, which is a handy tool that will calculate these things for you. ksp.olex.biz. Now, while the mathematics for calculating the transfer time is relatively simple, it's really nice to have a tool to do it, and that tool for most people is ksp.olex.biz. That's assuming you don't want to use any of the autopilot plugins. Now, so what you do is you select your target, say you're at Kerbin as you start out, you want to go to Moho, you do the mathematics, and it will tell you that you have to wait until Moho is there, 251 degrees behind you. And that means that when you burn here, in a certain amount of time you'll end up there, but in that time Moho will have probably gone all the way around and come around there and completed the orbit. Similarly, you have Eve. Click do the mathematics. You'll see that you want to burn when it is 53 degrees behind, or 54 degrees behind you in the orbit. For Duna, the value is 44 degrees ahead of you. And for Joule, you want to burn when it is 96.6 degrees ahead of you in the orbit. And again, same thing happens. You'll burn here, come out, and then by the time you get here, Joule will have travelled that distance. Now, you can also do it, it will also tell you for Elu and Dres, but because those are elliptical, the values are much more approximate since there's a lot more variation in the angular velocity through the orbit. But yeah, use that tool to get you the angles you need, and from there you can then approximate an actual burn using the maneuver nodes. Okay, so we are going to try and go to Duna. Now, based on the web page, we know that we've got to wait until Duna is 44 degrees in front of the planet Kerbin. So we are going to have to measure the angle between Kerbin, the Sun, and Duna. And this, obviously, I'm just estimating it, but that looks more like 135 degrees, right? So we need to come 90 degrees around. So what do? Well, we time accelerate. Minor problem is if you're in a 100-kilometer orbit, you're limited to 50 times time acceleration, and it takes a really, really, really long time for this. So, I advise having another spacecraft you can switch to. And if I look in here, I've actually put... Whoa, there we go. Let's actually stop the time acceleration. I've actually deployed some spacecraft on the ground at the Space Center. I have one that's called Timekeeper, so let's use Haystack to pilot it. And it's just a rover. And because it's sitting on the ground, I can actually time accelerate much faster. I can do like 100, I can do 1,000, I can do 10,000. We can do 100,000, wah, and freak everyone out. I'm sorry if that caused a seizure. I tried to kill it very quickly. So now, with our ability to time accelerate very rapidly, we zoom out, and we're now waiting for the planet Kerbin to catch up on the planet Duna. Now, what's going to happen is it's going to be moving around the Sun, but we're going to be moving around the Sun faster. So let's watch this happen, right? Times 1,000, times 10,000, moving very slowly, times 100,000, and now we're starting to move, right? So I'm going to try and keep everything rotating. Right, now the reason why Duna has to be 45 degrees ahead is because we're going to go through 180 degrees from our launch, right? Whereas it is going to be on a more distant orbit and therefore will travel less than this 180 degrees. So you see that I'm estimating this by hand. Is there a better way to do this, I'm hearing you think? Well, let's pause. There is a better way to do it. There is Mechanical Jeb, and it has this object in Mechanical Jeb version 1 that actually tells you the phase angles. Hello? Yeah, that's far better, and actually you see this says 74 degrees. Excellent, so we can just click and watch this go down. Much more civilized. Now, we're not having Mechanical Jeb actually perform a maneuver for us, it's just sitting on an object on the surface and keeping track of the phase of Kerbin relative to these planets. There we go, 47 and 6, 45. And actually, so here's one thing is that, let's get it to 44. There we go. Okay, we overshot just a little, but that's not a problem. Now, we have to switch back to our spacecraft in orbit, and we're going to use this one. It was called DRES mission originally, but as it happened, we ended up going to PAL. So we are going to have to set up our maneuver node, and if you remember, we want to burn roughly on the 45-degree position behind the planet, and we need to add about 1 kilometer and 1 kilometer 50 meters per second, maybe. Well, I'm just totally guesstimating. I'm going to start with that, and you see the maneuver node is actually giving us a nice feedback to tell us how fast we're going. I get pretty good angle there on that, I have to say. And if I set up Duna as my target, it shows me nothing. That's great. So now I want to come back in and adjust this to see if I can get any feedback. Unfortunately, because of the way this works, the encounter is going to be inside the sun, or the visibility for the actual encounter is inside the sun. There, look, we have target position at closest approach. I was going just a little too fast. So let's see if I can make these closer. So thanks to the power of time warp, you don't have to sit and watch me for a whole minute messing around with this. But yeah, I try to get things down a little, but ultimately I think I'm a little early, and the reason is, as we come out, you actually see that I'm arriving at Duna and I'm arriving slightly behind it. And that means that I didn't wait long enough. And because I'm arriving behind it, it will actually be moving faster than us and will be harder for us to catch up. So in this situation where we're coming up behind an outer planet, it's wise for us to actually run time forward and catch it on the next orbit. And so that's what I do, and set up another maneuver node, try to get an encounter, and there now, what does it say? 464. See, by waiting one orbit, I've managed to get 464,000 kilometers, so that's closer, and maybe I can get closer still. So I wait one more orbit, and once I get through the node, I continue to mess with my vector, and immediately I get myself an encounter. An actual sphere of influence change, but I think that one's actually too high velocity, so I mess around a little more trying to reduce the prograde vector, because ideally you want to arrive at the opposite side of your current location, right? And there you go, I get an orbital encounter right there with the planet Duna, so that is us using the phase angles to get ourselves an encounter. Now we actually have ourselves an encounter here, right? But we want to get this as close as possible. So normally what we want to do is add a correction burn. Now typically with a lot of planets there's a difference in inclination, and you see here there's actually the descending node. The problem I find a lot is that there's actually two orbits here. There's the departure orbit and there's the orbit that you're actually going to be on after the SOI. So this is the one that I've got, and I can actually just add a very small correction here to hopefully bring me closer to the plane. Now it says descending node, so I want to add some ascending velocity to this, and it's actually going to be very hard to see the effects of this because I'm going to have to tweak it here and point it here and so on. You see I'm actually bringing my encounter distance down very little. They're 24,000. Let's bring it like 10 meters and 10 meters per second. There, bringing it down. And 22,000 kilometers. And 22. Now the other one you can adjust here is you can adjust your normal and anti-normal, and that will sometimes give you corrections that will be useful. There we go, we're bringing this down. And we want to bring this as close as possible. And there we go, 8,000, 7,000. Now, you want to... Oh, there, and I overdid it. I got lost there. 7,000 kilometers. And, you know, we can continue to adjust this, but, you know, you get the idea. You're going to be working with the maneuver nodes. Now, normally you want to do these corrections near the descending or the ascending nodes. There's basically a fundamental problem with, you can't simply do it in one burn always. not every planet is easy to get to with a single burn, and the reason is the inclinations can be very high. So unless your phase happens to line up with an ascending or a descending node, you're probably going to need a correction burn partway through. Now, depending upon the positions of the nodes, they might be conveniently located, they may not be. You're going to have to make that decision for you. So that's how you do it by hand. Of course, there are other tools to make things easier still. Okay, so obviously in the case of Mechanical Jeb 2, it actually has this maneuver node planner, and you can set your target for Duna, go along to the transfer, match planes, transfer to another planet and click go, and it will generate a maneuver node. However, this one has decided to create a completely different maneuver node from the one I expected. This one has decided to wait until we're here before burning. If I bring up the maneuver node, or if I bring this up, you see that it's decided to wait 237 days. That isn't so good. Let's remove all nodes. I guess it's deciding to wait a whole other orbit. It thinks I've missed it. It's missed that opportunity. So let's say we're going to Joule. When does it say that next one is? Go, and it says it's going to create a maneuver node in 111 days. It's going to go around almost a whole orbit and then burn there. Well, that's great, but I'm not wanting to wait another 101 days. Is there anything else I can go to? How about ELO? Let's set that as a target. Go. And what does it say? Oh, it's going to burn in 4 days. Of course, it's not, because ELO is at such high inclination, it's going to miss it. So you can then go over to the next one and say, fine-tune closest approach to target. So I'll go. There we go, we get actually a relatively good approach there. So it adds 2 maneuvers. Now I can look at the maneuver node editor and see the actual values here. And in this one, it does a 2.1 kilometer burn initially. And the second one is a burn of, it's about 300 meters per second total. So that's a relatively decent thing. And then, of course, you've got an encounter here to slow down, and that's a whole different kettle of fish. You're going to need to slow down at the other end. Now, there is one really nice trick that you might want to know with Mechanical Jeb 2 and with Alarm Clock. Now, you remember how I highlighted an object? Let's say we want to go to Moho. Well, let's say we don't want to go to Moho. What we can do is we can say transfer to another planet, go. Right, now it'll create as a maneuver node 12 days in advance. So you can add that to your mission list and then call it Moho Window. Right, and all we want to do is kill warp time, margin minutes. Yeah, give us 3600. Oh wait, no, not 3600 minutes. Let's give us 5 hours warning, or 360. Let's give ourselves 6 hours warning. 1 whole Kerbin day. Add that as an alarm. So now we have Moho Window in there. So let's remove all the nodes. Let's select Eve and set as target. Go. And it says there's a window in 82 days. So let's add a window for that. Alarm name will be Eve Window. And again, 360 minutes, add the alarm. And you can do this for all of the stuff. And the beautiful thing is, right, the alarms are good for every single spacecraft that you have. So you can set up alarms using Mechanical Jeb and Kerbal Alarm Clock, and it will tell you how long until the next window will be. That's a great thing for planning. Even if you're not actually going to use them, you can just set them up by having a probe sitting in orbit, calculate the orbit, and you'll have a countdown to when the next launch window for these targets is appearing. So that's a brilliant tool to have. Even if Mechanical Jeb sometimes is great with the maneuvers, sometimes it's not so good. You see that I obviously had a pretty good maneuver set up, but Mech Jeb decided to wait a whole other Kerbin year, in fact more than a Kerbin year, to go to it. So the other tool that I would advise looking at is one. There's one. Actually, I've got it on. Where is it? On planetary mission here. And let's fly this one. Now, this one has old school mechanical jeb on it. As you remember, important. Phase angles, very nice. But there's a better version of phase angles, and it has no autopilot built in. It just has the angular calculations and everything built in. Now, the angles aren't one for one. They don't correspond for one for one. You have here, you have theta, psi, delta V, and the closest approach, right? So these values, when they get close to 0, that is when you are at a launch window. And you see that we're close to a launch window for Duna, right? In fact, I proved it. I can get a pretty good encounter with Duna if I go now. So, yeah, 359, whatever. That, because, of course, 360 degrees is a complete orbit, that means we're very close to it. So I, of course, shall demonstrate this. I shall set myself out on this orbit once again, and I should have probably been doing all this talking while burning, because talking and burning without burning wastes time. And of course the maneuver node comes up and sits itself in an inappropriate and annoying place. And set target, and once again, no, you are very annoying sometimes. There we go, bring it back up. I think we need hotkeys to maybe bring up the maneuver nodes. That would be a great idea. Just click plus or minus or something and show the maneuver nodes. Okay, and we're pretty close there. Nope, it's moving us further away. Closest approach, target position at closest approach. So we're a little behind again. Can I get this better? Yeah, that's that. You know what? I'm just going to go with that, and we'll fix it when we're in flight. And add maneuver. Let's see what that says. 77. 81. No, let's go this way. 55. And maybe a little more velocity. Oh, look, there we got ourselves an encounter. Using a small velocity. So that's us set up. We've got our maneuver node, so of course we can tell mechanical jab, set us up for node, and we'll run as a countdown to it. Orbital operations, warp to node. With actually, this is an important one with this. Let's be careful before I start warping and come out of map mode here. First of all, we want to make sure this is our engine, okay? And we'll start this slightly. Okay, now it tells us it thinks we're going to need 24 minutes to do this burn. So I actually want to do a lead time that's way long. So let's not bother. Let's just set ourselves up prograde. Forget about orbital operations. And we'll just zoom in and watch myself come around. It says 24 minutes, but I hope it doesn't take that long. So we're going to come around the back here, and then once we reach over the Terminator, that's probably a good time for us to start burning. And there, that's us. No, that's Driz mission. Planetary missions. Planetary mission is the one we're on. There we go. Okay, so hit prograde, and we look down. There's the sun there. There's the sun setting behind us, and we shall burn like our life depends on it. And it recalculates and now says 8 minutes. So actually that's pretty good. The node is in 4 minutes, the estimated burn is 8 minutes, so we're going to split this roughly 50-50. That's a big problem with the nuclear engines, obviously. You need to take account of this in all your burns. Anyway, I was explaining Protractor. Protractor is a much nicer instrument in a lot of ways. What it will do is this psi will actually tell you when it thinks you should start burning. And in fact, you see it counting down here, so when that hits 0, that's when I was supposed to start my engines. And that, if I have adjust psi set, then it will adjust based upon my presumed thrust to weight ratio and everything. So that's a great tool for planning. It doesn't actually do the maneuver nodes for you, it just tells you when to do the maneuver nodes and when to start burning prograde and when, how much delta V and everything is left. It's better than Mechanical Jab 1. It may not be better than Mechanical Jab 2, but it does have that warm fuzzy feeling you get from entirely flying things manually. It's up to you. So to summarize, interplanetary transfers are actually relatively simple. You just need to make sure you have a rocket that has enough delta V to get you there. You need to make sure you are doing it round about the launch window. You need one burn to put you onto an eccentric transfer orbit, and then you need probably a second correction burn when you're about halfway there to make sure that you actually get a really good encounter. And this correction burn is especially important with inclined orbits. To finally get your launch windows, you can use any of the 3 tools I've talked about, any of the 4 tools if you include the website. It does help to have actual in-game numbers, since holding up, protractors to the screen is not the most efficient way. I personally like Protractor a great deal, but I also like the way that I can take MechJab 2 and integrate it with Kerbal Alarm Clock to give me a series of launch windows. And of course, returning to Kerbin is essentially the same set of operations in reverse. And yeah, if you need to land, you're going to need to set yourself up for landing. I'm not going to cover that here. But otherwise, I hope you enjoyed this. Fly safe!